Might Proxima b at some point be another Earth-like planet? These are theories everybody continues to make. Humans are fascinated by the search for a new, habitable planet and the possibility of alien life elsewhere. There have been a lot of theories, and the fact that Proxima b has sent signals makes people think there is more to it. We still don't know if these are planet-wide messages or just echoes of our own scientists' signals, despite all these signs. Frequently, these signs end up as reverberations. In seeing if these signs are genuinely from Proxima b, researchers desire to decide whether outsider life exists. As of late, the James Webb Telescope identified counterfeit lights on Proxima b. Assuming you're keen on finding out about different planets and our advancement in tracking down substitute life, buy into our channel. We make content about space and discuss developments in science. Assuming that you like this substance, remark underneath and share this video with your companions. Let's return to our video now. A GZV dwarf star, Proxima Centauri, is about 4.2 light-years away from our solar system. Accordingly, the star is known as Proxima Centauri. The star is the one that is closest to the Sun and our solar system. It was named Alpha Centauri and horologied by Johann Bayer in 1603. The name came from the stars rising around early afternoon while a few heavenly bodies like the Moon and the Sun were in an orderly fashion. Proxima Centauri is otherwise called Alpha Centauri or Alpha Centauri. There are 4 named stars in a line in this one-star system. The Proxima Centauri is at the focal point of this framework. Alpha Centauri A, also known as Rigel Kentaurus, and Alpha Centauri B are 2 faint dwarfs in addition to the 4 stars. These make up the main part of the mass, however, are excessively weak to be seen by the unaided eye. The framework is found 23 degrees away from the boundary of the well-known Furrow asterism in the star grouping of Centaurus. Despite the fact that Proxima b is a rough planet, there is still expectation that it could have extraterrestrial life. Scientists have arrived at Proxima b in their search for any other life. They trust the likenesses to Earth's size and the distance it is from its small star make it a suitable choice with regards to planets that can oblige life. Even though all of these are just theories, there is hope that some of them could be true. There is a lot to find out about Proxima b and the circle it takes, so remain blocked and find out. You can likewise look at a portion of our other substance connected with extraterrestrials. Do you truly trust there's one more life out there? Leave a message in the box below. What interests a great many people about Proxima b is its comparability to Earth. Concentrates on show that Proxima b is an exoplanet that circles a M-type star. It is thought to be 1.27 times heavier than Earth. Proxima b requires 11.5 days to finish a circle of its star. Since its discovery in 2016, numerous scientists have investigated it. Despite the fact that Proxima b appears to be like Earth, certain elements make it appalling. For one's purposes, the planet is excessively near its star. Accordingly, it continues to get outrageous bright radiation from the star. It is estimated to be hundreds of times greater than the Sun's radiation. The radiation is solid to such an extent that it strips away even the lightest hydrogen atoms with time and does likewise to oxygen and nitrogen. There is more to Proxima b than meets the eye, despite the majority of people arguing that it should be habitable because it is the same distance from its star as the Earth is from the Sun. Distance doesn't consider whether there is water in the world. Additionally, there is no evidence of a living environment. The air on Earth makes it livable and not Mars. The right air makes it feasible for environment guideline and a water-accommodating surface. Additionally, it protects living things from hazardous space weather. In the event that you're with us up until this point and haven't bought in yet, require one moment to stir things up around town button. It makes it simple for us to continue to make content like this that you'll cherish. Let's now examine the reasons why people believe that the James Webb Telescope will assist us in determining whether or not Proxima b contains life. After being delayed since 2011, the James Webb Telescope was finally launched in 2018. Many changes must be made to guarantee it gave exact pictures. During creation, Loeb made sense of that, assuming that a planet like Proxima b could ingest light from its star. It could likewise retransmit it as infrared light. The James Webb Telescope was specifically designed for infrared light observation. It is able to take pictures of this light on a planet's surface and search for patterns that could indicate whether the planet has water or an atmosphere. One reason why space telescopes are liked over ground-based ones is that by being over the air, they don't need to look through the moving air to see profound into space. As a result, they have a better view of what happens outside the solar system than the majority of ground telescopes do. The other benefit they accompany is that weather conditions changes on Earth don't influence them, and cosmologists should rest assured they're getting a reasonable perusing. The main disadvantage to having a space telescope is that fixing it is costly, assuming something turns out badly. There have been situations where a little blemish in a space telescope requires an entire mission into space to fix it. Observing planets like Proxima b is difficult due to these costs. With the James Webb Telescope, we have no choice for salvage. Since it was launched from a distance of more than 1.5 million kilometers, which is further than any human has ever traveled, no rescue missions are possible. The James Webb Telescope accompanies a bigger mirror. Hence, we can see way back to the start of the universe, practically 13.7 quite a while back. The further away an article is, the further in time we get to see it. This is because it takes a long time for light to return to us from an object. We can now see more distant galaxies in our universe with greater certainty thanks to the James Webb Space Telescope's ability to observe the universe at a longer wavelength in infrared light. As a result, it is now easier to observe planets like Proxima b because it has moved light out of the visible spectrum and into the infrared. Tabor and Loeb have a size of counterfeit light as a small portion of how the sun enlightens and ponders the day side of the planet. At 0% on the scale, it would be reasonable to assume that there is no light at all on the planet's night side. At 100%, it implies that the planet's night side is similarly basically as splendid as the day side. There has been a speculative human progress on Proxima b utilizing this sort of light, and most researchers accept it is like the good old days on the planet. According to the studies, the James Webb Telescope could detect the artificial light by 85% if the night side of Proxima b was illuminated to 5% of the natural day side. Assuming that the enlightenment arrived at 9%, the telescope would distinguish up to 95%. Despite the fact that 5% brightening seems like a modest number, we're discussing the light from a star to the extent that Proxima Centauri is contrasted with our Sun. Even though our illumination is 20,000 times dimmer, our star still provides a lot of light. This fundamentally intends that at 0.01% of light, we are as yet reflected in the heavenly enlightenment. To put it another way, the James Webb Telescope would not be able to detect any deceptive civilization glowing like Earth on Proxima b. The stars should be multiple times more brilliant. This situation is inconceivable. Proxima b's close proximity to its host star raises the possibility that it is tidally locked, with one side of the planet always facing the star and the other always in darkness. To reflect sunlight from the day side of the planet to the night side, a civilization on a tidally locked planet might need to concentrate on lighting up its infrastructure. Tabor and Loeb have only speculated on this, and there is no evidence to support their claims. The world's brightening should be visible from space and is known as the airglow. When looking at the world from 300 miles above its surface, the majority of people are left wondering why it is surrounded by intense hues of red, yellow, green, and purple light. The airglow happens when iotas and particles in the upper air produce light to deliver overabundance energy. On the planet, the airglow can happen when iotas and particles get ionized by daylight and catch free electrons. The gleam appears to be like an aurora. Then again, actually auroras are driven by high-energy particles from the sun-based breeze. Solar radiation drives the airglow every day. Since the James Webb Telescope send-off, researchers have been finding out if seeing different planets in distant galaxies is adequate. Despite the fact that it is the uttermost satellite telescope sent off, it actually gives almost no information expected to track down planets with life in different universes. Accordingly, there have been discussions about creating far superior telescopes. These endeavors frequently cost a lot of money and require a lot of trial and error. The James Webb Space Telescope send-off was 7 years late because of these issues. Along these lines, it is provoking for most researchers to foster better advancements that can be sent off further into space. Notwithstanding this, the James Webb Space Telescope results are promising. Before long, we could be aware assuming there is life on Proxima b and different planets. While work is as yet being finished on additional telescopes, it is trusted that the culmination and send-off of the Tenable Exoplanet Observatory, HABEX, will alter space study. HABEX's estimated completion time is 2030, which is far into what's in store. In any case, researchers say that this telescope will see a lot further into space than the James Webb Telescope and give us results all the more rapidly.